Did you know that penalty kicks in football follow the mathematics of John Nash? He was the real-life mathematician behind the film A Beautiful Mind, and he won the Nobel Prize in economics in 1994 for his work on game theory. Game theory is the mathematics of strategy. It shows up in economics, biology, and even on the football field. But it's difficult to find good data that fits a simple mathematical model, especially in complex games like football. However, in an interesting study, economist Palacios-Huerta focused on one specific part of the game.
It's very hard to find good data, but the penalty kick is ideal. Only two agents, and always in the same position. After some math, you solve for the Nash equilibrium, and it turns out that it has some predictions.
He collected data from 1,417 penalty kicks across various European football leagues over 5 years. He observed many things, but here we'll focus on just one: the simultaneous choices made by the kicker and the goalkeeper, whether they went left or right. The success rates from these choices can be summarized in a payoff table, with the rows representing the kicker's choices and the columns representing the goalkeeper's. Now, the goalie wants to ensure that the kicker has no preference between the two sides, because otherwise the kicker could exploit that. Suppose the goalie dives to the left with a probability of P and to the right with a probability of 1 minus P. This strategy would make the kicker indifferent between shooting left or right if the expected payoff from both choices is the same. We can express this condition with an equation. If the kicker chooses left, he scores 58% of the time when the goalie dives left, with probability P, and 95% of the time when the goalie dives right, with probability 1 minus P. If the kicker chooses right, he scores 93% of the time when the goalie dives left, with probability P, and 70% when the goalie dives right, with probability 1 minus P. Solving this equation shows that P must be 42%. So to make the kicker indifferent, the goalie should dive left 42% of the time. We can do a similar calculation to show that to make the goalie indifferent, the kicker should shoot left 38% of the time. So that's our mathematical prediction. But what do the players actually do? These are the averages calculated from the observed data, and as you can see, they closely match the predicted numbers. But that doesn't mean the players are solving equations in their heads. That's the beauty of mathematics. It can emerge naturally in strategic interactions, even when no one is consciously doing the math.